Good day, viewers all over the world. You are welcome to Troy online class. Today we want to look at in-depth analysis of the nature of root of quadratic equation. We recall that the solution of ax squared plus bx plus c, which is the general form of quadratic equation, is this. When we use the formula, this is what we are going to get. And we actually talked about discriminant. You want a discriminant. B squared minus 4ac is represented as d, which is called the discriminant. What is the implication of this discriminant? This discriminant is actually, we actually use discriminant to know the nature of root. That is, how does the root of quadratic equation will look like? That is what discriminant is used for. Then the first case, case 1, is when we have the discriminant to be less than 0. If the discriminant is less than 0, it simply means that the roots are imaginary. That is, the root of quadratic equation does not exist in the real sense. They actually imaginary. When discriminant is less than 0, it shows that the root, the equation has a complex root. That is, maybe at the end of the day, we are going to get value of our x to be equal to something in the form of maybe square root and plus or minus maybe 4. At the end of the day, we have x to be equal to 2 or square root of minus, when you have, no, we have the nature will be in form of maybe minus 4. We have something like minus 4 there. One of the roots, we have something like minus 4. Then when we have something like the square root of minus 4, you cannot get that in the real sense. It's not possible. You can't get the answer. You use calculator, it's going to give you error. One of the roots, we have something of this nature. And at the end of the day, x will actually be minus 4. We have minus 4 multiplied by square root of 1. We split it like this. So that square root of minus 4 will be equal to, it will be square root of minus 4. If you want to express this now, we can only get the solution in the complex sense. We can't get it in the real sense. How do we get it in the complex sense? We now split this to say x is equal to square root of minus 1 multiplied by square root of 4. So at the end of the day, this will be 2. Square root of minus 1 will be high. That's what we are going to get. So the value of x will be too high. The solution when discriminant is less than 0, we can only have the solution in the complex sense, not in the real sense. In the real sense, you can't get it. We are still going to talk about complex number. We can never get the solution when the discriminant is less than 0 in the real sense. We can only get the solution in the complex sense. And this is how the graph will look like. X, we are going to have something of this nature when the discriminant is less than 0. So the graph is not going to cut across x-axis at all. We know the root of the equation. We pick the 2 points along the x-axis to be the root of the equation, which will represent the two values of x equal to this or that. But when the discriminant is less than 0, we cannot get that. We go to case 2. Case 2 is when the discriminant is greater than 0. So what is the implication of this? When the discriminant is greater than 0, it simply means that the roots of the equation are real and distinct. They have different roots. That is, this type of problem is when we have x is equal to 2 or minus 4. When the roots are distinct, they are real and distinct. They have different value. Then the implication is that we are going to have something of this nature. It is going to cut across x-axis like this. So this will be the discriminant. When the discriminant is greater than 0, we are going to have something like this. These are the roots of the equation. Something of this nature. We pick the root from along the x-axis, the 2 points where the curve. Then when it's greater than 0, that is the type of curve that we have. Then we use the nature of root also to know if the curve, it is the value, the coefficient of x squared that determines that it will be, the curve will look up, will face upward or downward. It is the value. It is the value of the coefficient of x that will tell us that. Then the third case is when we have case 3, when the discriminant is equal to 0. When the discriminant is equal to 0, the implication is that the roots are real and equal. That is the implication there. When the discriminant is equal to 0, the implication is that when the discriminant is equal to 0, the implication is that the roots are real and equal. For instance, when we work quadratic equation, we get x to be equal to 2 twice. When we have something like this, or x equal to 5 twice, it simply means that the roots are real, but they are equal. That is the implication of that. When the discriminant is equal to 0, it simply means that the roots are real and equal. So please let's note that we have under the nature of root, we have 3 categories. the case 1, case 2, and case 3. We can have imaginary answer under complex number depending on the nature of the quadratic equation. So once we have imaginary answer, like the case 1, the solution does not exist in the real sense. We can only get the solution in the complex sense. And in our next video, we are going to give example on each of these. Thank you, and God bless you all.